pink film. So again, wave numbers on the x-axis from 4,000 down to 600. Again, this is a transmitted spectrum, 100% to 0%. So again, we see pretty strong bands here just below 3,000 wave numbers. So we said that's indicative of a saturated CH stretching motion. And so we know that we have CH groups in this film. But when we get down into this region, we see a number of bands that we didn't see in the polyethylene spectrum. And so this band is about 1918, a little bit over 1,700 wave numbers, between 1,700 and 1,750. So we have a strong, sharp absorption band between 1,700 and 1,750. Anybody remember what we said that was? That's very characteristic of a carbonyl group. Okay? So anytime you have a strong, distinct absorption band between 1,700 and 1,750, that's very characteristic of a carbonyl. Now, if you look at the structure of those three different films, I don't see any carbonyl groups. So why do we have a carbonyl group in this particular film? Where the carbonyl comes from is, this film is actually polyvinyl chloride. So Reynolds wrap is polyvinyl chloride. The carbonyl is actually a plasticizer that is added to the polyvinyl chloride to make it flexible. Polyvinyl chloride is normally a very brittle polymer. So if you made a film just out of polyvinyl chloride by itself, it wouldn't be flexible. It would be brittle and it would just like break if you tried to bend it. So they add a plasticizer to the film to make the film pliable, to make the film flexible. That plasticizer, it's usually a derivative of adipic acid, which is an organic acid. And so organic acids are going to have carbonyls. So the carbonyl that we see is not from the polyvinyl chloride itself, it is actually from the plasticizer that is added to the film to make it flexible. And then you can also see we've got absorption bands down here below 1,000 wave numbers. This would be typically where we would see the carbon-chlorine bands. Okay, so remember, chlorine is a big, heavy atom. It vibrates slowly, and so we see the carbon-chlorine bands down here below 1,000 wave numbers. So by looking at this and knowing a little bit about the chemistry of how they make polyvinyl chloride films, we can determine that this is a PVC film. So we see CH, we still have CH in polyvinyl chloride. We see these low frequency vibrations that would be characteristic of a carbon-chlorine vibration. And then kind of the telltale one here is this carbonyl, which is not from the polyvinyl chloride itself, but is from the plasticizer that they use to make the film flexible. Okay? So Glad wrap, polyethylene, Reynolds wrap, polyvinyl chloride.